So hello everyone, let us solve another GfG problem of the day. The problem name is Kth Smallest. So let us read the problem statement first. So given an array ARR and an integer k where k is smaller than the size of the array, our task is to find the kth smallest element in the given array. And it is given that all the array elements are distinct. So array will contain unique elements. Now they have said that we can't solve this question with the help of inbuilt sort function. Otherwise it would be like just sort the array and return the element present at k minus 1th index. So we can't use sort function, so we need to find some approach which doesn't require sorting. So this was the question, and the expected time complexity is O of n plus maximum element, and auxiliary space or space complexity is O of maximum element. So let us see this first example and try to understand the question and find some solution out of it. So this is the first example that they have given. So this is the ARR array and k value here is 3. That means we need to find the kth smallest here, that is third smallest element here from this given array ARR. So let us see how we can find this answer. So if we just try to sort the array, although we don't have to sort the array, but just for explanation, let us just sort the array. The array would look like 3, 4, 7, 10, 15 and 20. Now kth smallest here would be third smallest, and third smallest we can see it is 7. So that's why 7 is our answer. So this is what the question is actually saying. Now how to find this answer, because we can't use this sorting technique. They have already said in the question. We need to solve this question without inbuilt sort function. So how we can find answer for that? Now one way is to use the max heap, where what max heap does is it will always keep the largest element at the top. So in the max heap, always the top element is the largest element from the given array. Now what we can do is we can maintain the max heap size to be k. Now why k? Because if the largest element would be at the top, that means smallest element would be at the bottom, right? So this would be the first smallest element, and size of the max heap would be at most k. So if this is the first smallest element, this would be the second smallest element, and so on up till when we reach here. When we reach the element which is at the top, it would be kth smallest element, because we have maintained the size to be k only. Now what happens if size exceeds k? Because we know that the array element can contain more than k values. So what happens if our max heap size got exceeded from the k? So nothing, it will remove the top element. So whatever top element would be present when the size of the max heap will exceed k, it will just remove the top element, and by doing this we will maintain the max heap till k elements only, and this is how we'll get the answer. So hope you get the idea why we are making the size of the max heap k only, because the intuition is simple. If we are using max heap, the smallest element would be present at the bottom, second element would be second smallest element would be the second element from the bottom, and so on and so forth. When we reach the top element, it would be the kth smallest element. So let us dry run this max heap approach on this test case. So let me draw max heap. So we will maintain the size of the max heap till 3 only, because here our k value is 3. So let us put elements one by one. So first we come across 7, so we put 7. Then we come across 10, so we'll put 10. Then we come across 4, so we'll put 4. Now we came across 3, so it will not be in this order actually. It would be something like 4, 7 and 10. And now we came across 3. So what it will do, it will again heapify and all that inside it. So it will look something like this: 3, 4, 7 and 10. But the size of the max heap here is exceeded. It is 4 elements, but we need to have only 3 elements in our max heap. So what it will do, I have already told before, it will remove the top element. So after this, our max heap would look something like this. So 3 would be at bottom, then 4, then 7. Now we'll come across 20. So 20 is the largest element, so it will come to the top. Again the size is exceeded, so it will take this top element and remove it. So it will remove this. Now we come across 15. Again it is largest element till now, so it will be at the top. Again the size of the max heap is exceeded, so it will take this 15 and remove it. So we have iterated all the elements in this ARR array, and that is the end of the array. So whatever configuration we have till now in this max heap, the top element would be the kth smallest element. So here the top element is 7. So 7 would be our third smallest element, and as we can see, our answer is also 7. So this approach works, but there is one problem. The expected time complexity that they have given is, it should be O of n plus maximum element, and space complexity should be O of max element. But here the time complexity would be like, let's say there are n elements in the array, so n elements, and for the inside it will do some heapify and all that, so it will take log k time, because our size of the max heap can be at max k. So the time complexity would be n log k, and space complexity would be simply k, O of k, because we are storing at max k elements inside our max heap. So this is the time complexity and space complexity. So it is not matching to this one. So this approach is fine, but according to question we need to more optimize it. So let us see another approach how we can do this. So one thing is for sure, that we can't use the sorting technique, we can't use the max heap technique. So let me give you another solution which will fulfill the time complexity as well as the space complexity without sorting and all that. So first what we will do, we will find the maximum element present in our ARR array. Now why we are doing this, I'll tell you afterwards, but for now just see how the algorithm will work. When I'll dry run this entire algorithm, you will understand how this is working. So first we'll figure out what is the maximum element. In this case it is 20. So what we can do is, we can create a frequency array which will count the frequency of each and every element. Now here they have said that every element is distinct, so everyone will have frequency of 1 only, but still we are finding out. I'll show you why we are doing this, but for now just see how the algorithm will work. So we'll create a frequency array of 20 plus 1, that is max element plus 1. Now why plus 1? Because to store the frequency of 20 we need index 20, and to get the index 20 we need to have size of 21, because our indexing in the array starts from 0. So we'll create a frequency array, and initially it will be all 0. It is a kind of visited array, not a frequency array. You can say it is kind of visited array which will keep track of how many elements are present in the range from 0 to maximum element. So you can say it is as a visited array instead of frequency array. So after figuring out all the frequency and all that, what we can do is, we can iterate from 0 till the maximum element, and whenever we find someone's frequency set, that means that element is present in our ARR array, what we can do, we can keep a count named current. Initially it will be 0, so whenever we find some frequency of I, let's say, is equal to 1, we will increment our current plus plus, and whenever this current will become equal to k, that means that is our kth smallest element. Now how this will work? Because it will obviously give the kth smallest element, because we are starting our iteration from 0 and going till the maximum element. So even if we are not sorting, we are still going in increasing order. So that is the main idea behind this algorithm. We will go from 0 till the maximum element. So it will we are not using sorting, but still we are able to find our answer in the given time complexity and the space complexity. So let us dry run this algorithm on this sample test case. So first what we need to do, we need to find the maximum element from this ARR array. So we can just iterate from first element till the last element and we can easily figure out what is the maximum element. So here our maximum element, let's say we store it in some variable maxi, it is 20 here. So what we can do is we can create a frequency vector of size 20 plus 1, that is 21. So let me draw this frequency vector. So this is the frequency vector. Initially all the elements will be like 0. I'm not writing it, I'll just mark the indices which are present in this ARR array. So what we can do, we can again iterate through this ARR array and keep marking the elements which are present in this array, ARR array. So first we'll go to 7 and mark it as 1. Then we'll go to 10, we'll mark it as 1. Then 4, we'll go and mark it as 1. So these indexes are representing the elements of the array. Then we'll come across 3, we'll mark it as 1. Then we'll come across 20, we'll mark it as 1. And then in the end we'll come across 15 and mark it as 1. So rest all will be 0. So let me just write this. So rest all are 0. So we have made our frequency array. Now what we need to do? We need to iterate from 0 till the maximum element and keep incrementing our current count whenever we find some element is present in this ARR array. So we can keep a current counter CURR, initially 0. So first we will be at index 0. So we can see that index 0 has value 0. That means this 0 element is not present in our ARR array. So we can move forward. Now we come across 1. Now 1 is also 0. That means 1 is also not present in our ARR array. Then we'll come across 2. Then we'll come across 3. Now at 3 we can see that it is 1. That means this 3 is present in our array. So we can increment our current by 1. So our current will become equal to 1. Then we come across 4. 4 is also having the value 1. That means 4 is also present in our ARR array. So we'll again increment our current value, it will become 2. Then we'll keep on going and we'll come across 7. 7 is also present in our ARR array. So we'll increment our current. Now it will become 3. Now what does that mean? Now our current value is 3, which is equal to k. Now it simply means that we are iterating from 0 and we are keep on going till the maximum element, and whenever we are seeing element that is present in our array, we are incrementing our current, and whatever element we are seeing, that is that will be in increasing order. So whatever element we are seeing, let's say we are present at the third element. We found 3 elements till now, so we are at the third element. So this third element would be nothing but the third smallest number in our entire ARR array. Now what we can do is, whenever our current value will become equal to k, that means this element that we are currently present at is the kth smallest element. So we can just return I from here. Why I? Because we are iterating from 0 till max element with the help of I pointer. So this is how this algorithm will work, and it is also following the time complexity and space complexity which they have provided. So how it is following? Because we are iterating to find the maximum element and storing the frequency. So we are iterating till n elements. So it will be O of n. plus in the end we are iterating from 0 to max element, so it will be O of n plus max element. And space complexity, you can see that we have a frequency vector of size maximum element plus 1, so we can simply say that it is O of max element. So this follows our time complexity as well as space complexity. Now let us write the code now and understand it more better way. So we will do step by step as we have seen in the algorithm. So first let me declare n variable which will store the size of the array. Now first what we need to do, we need to find the maximum element present in our ARR array. So let me define one variable maxi which will store the maximum element, and first we will iterate through the entire array to find the maximum element. So if our current ARR of I is greater than maxi, that means we need to update our max element to ARR of I. In the end we will get the maximum element. Now what we need to do, we need to store the frequency of each and every element present in our ARR array. Since the number of elements or array elements will be distinct, we can say that it is a kind of visited array instead of frequency array, but anyways we'll make a frequency array. Vector of int frequency of what size, it would be of size maximum element plus 1. Initially all will be set to 0. Now again we need to iterate through the ARR array to mark the frequency or mark the elements which are present in the array. So from I equal to 0 till I less than n, I plus plus frequency of ARR of I will mark it as 1. Now what we need to do, we need to start from 0, element 0 till we need to go till maximum element. So from 0 to maximum element we need to iterate, and we need to keep on incrementing in our current counter whenever we see any element having value set equal to 1. So first we'll declare a current variable, it will be initially 0, and now we'll be iterating from 0 till the maximum element and we'll iterate. Now whenever we see frequency of I equal to 1, that means this element is present in our array. That means we need to increment our current plus plus. Now if our current becomes equal to k, that means this element, this ith element is the kth smallest element in our entire ARR array. So we need to do nothing, we need to just return the I from here, and we can for like simplicity return 0 because we need to return something, and this condition will always get executed because they have said that k value is always smaller than the size of the array. So it can't happen that we can go outside this for loop, but still we need to return something, so we return simply 0. So this was the algorithm. So let us see what we are doing again. So first we are finding the maximum element, then we are storing the frequency of all the elements that are present. In the end we need to find the kth smallest element, so we are iterating from 0 till the maximum element. Whenever we find any element that is present in our array, we just increment our current. Whenever our current becomes equal to k, that means this is the kth smallest element because we are iterating in increasing order. So we can simply return I, otherwise we can just return 0. This will never get executed, but still if we don't return it will give us the error. So let us see if this code gets submitted or not. So yeah, our code works perfectly fine. So hope you learned from this video. Thank you.